I'd like to build a thing today I've been thinking about for a while. And I don't know if it's going to work, so I don't want to put too much time and effort into it. Consequently, I'd like to build it out of scrap, but it's looking like my scrap is just a bunch of scrap. Truth be told, I don't even have the right size stock that I need, so this is a last-ditch effort to just find something. A lot of this stuff might look familiar. This might be the taper from the taper turning video. Actually, we might be able to make this work, but we're going to have to do some restocking. Let's head over to the lathe. Now, I know we've never done this before, but if I get into too much of the details, we'll never get this thing built. Big picture, we're going to be running the lathe backwards. Feed rates are reversed. Keep a lot of mild steel filler on hand. Don't get too close. We're just going to be sort of throwing this from a few steps back. And then once we get closer to the end, you'll need some mill scale. Younger, more cavalier me would jump right in with a deroughing tool and just get to work. But patience with an operation like this really pays off. What I'm going to do is start by removing the chamfers. That way I don't risk any voids in the restocked part. Although this isn't strictly necessary, I want to take as few risks as possible. So I'm going to remove that step before we put on the majority of the material. Looks pretty good. Now with that smoothish, continuous cylinder, we can get to our deroughing operation. That looks pretty alright if I do say so myself. A couple of voids on the outside, shouldn't be a big deal. I think I'm going to try to add some saw marks on the end to add a dash of filler material here. You know, I really hate to boast, but that looks surprisingly authentic. Necessity is the mother of invention. But do you know who its deadbeat stepdad's second cousin's bowling partner is? That's right. This old. Today I'm going to try to build the thing I've always wanted to try to build. But before we do that, let's start off with a bit of a problem statement, just so we're all on board. I enjoy hand filing. I know how that sounds, and unfortunately, it gets worse. When filing, which usually happens at the vise, I sometimes need to file very shallow angles, and the vise often just gets in the way. If I try to keep going, my angle would change. Sure, I could shift the overhang as I work, but sometimes the parts aren't this big. I know some of you right now are having a conniption. I would too, and that I could just flip the part up in the vise tall-wise and have all the clearance in the world. But let's just all calm down a minute and talk about a very specific example. Sharpening stuff. There is no good way to put a kitchen knife in a bench vise and have clearance you need to get at the whole thing with your file. I could clamp it on the handle, I suppose, file one side, flip it, do the other side, but then I'd do a number on the handle. And the further I got away from the vise, the less support I would have. The closer I got to the tip, the less support I'd have for filing. Ideally, I'd want to clamp this knife flat. Maybe like that. So I can get to the cutting edge unobstructed at that 10, 15, 20 degrees, whatever. And if I had to do this right now, I'd simply hold the knife in one hand and go to town with the file. Likely holding the knife up at the angle I want and filing flat. Like a normal person, I suppose. But when has that ever been any fun? Truth be told, I very rarely need to put a hand file to a kitchen knife. But this isn't about need. This is about desire. Okay, granted, the kitchen knife was a bit of a weird example. What I do file often, however, especially this time of year, is my brush axe. Same problem here. If I put it in the vise, there's really no good way to get at that cutting edge. I can play games moving the thing around, but it's the same problem. There are lots of spots I just can't get to. So again, I just sort of lay it on its side and do my thing. In this case, you'd want to use a round file or a half round file. I apologize for being caught unprepared. How's about my fidget spinner? The cutting edge here is a lot shorter. There's a lot of body to hold on to. I could just stand this up in the vise and work out here on the end. But just look how silly this is. I'm a grown man filing into the air, for crying out loud. I'd be much less self-conscious in the solitude of my garage, not to mention much more comfortable if I could hold this flat and file horizontally. Like a gentleman. Samesies with it. Samesies with this axe. I do realize these are all cutting implements, but first, 'tis the season. And B, cutting edges very easily fall into this very steep angle, weird aspect ratio to hold contrived scenario we're talking about here. Again, there are obviously ways to file an axe. I'm just wondering if we couldn't do it a little more comfortably. You're watching a hobby machinist channel. Overcoming work holding problems like this is frankly machining 101. I could, for example, take a small block, drill and tap some holes, and use one or two strap clamps or hold downs of some kind, toe clamps, problem solved. However, although I do enjoy building things, at the same time I like to entertain the idea that I'm not a weirdo. Toe clamping your kitchen knife to file a new edge somehow feels like crossing a line. I know some of you out there might be thinking universal vise. Well, let me stop you right there. Yes, that solves the filing up in the air problem, but it'd still have clearance issues with the vise body itself. Good try though. I like where your head's at. Now, had you said magnetic vise, I made a technical drawing. I know we didn't all go to dental school, but I bet you can keep up. It's only really 4 parts. It'll be more than those as we put it together, but when all is said and done, I think it's just going to be 4 parts, maybe 5. And really, it's just a set of parallel jaws oriented horizontally. In fact, come to think of it, it's just a vise with some really thin jaws. Same exact principle. It'll be 2 nested tubes, one that slides inside the other one, the blue and the red here. A screw with, I guess, a captive head. Some sort of threaded block at the bottom. Maybe we'll put a spring inside to open those jaws when we slack the screw. Skip the whole captive head thing. I'm still working it out. There are 1 or 2 technicalities in here, but we'll get into those while we're making this. Hold on a minute. Now that I said all that out loud, I wonder if I couldn't have just started with a pair of ducting pliers. What do they call those? Like hand seamers. I wonder if they make those with a 90-degree bend instead of straight. Full disclosure, I was just going to buy a filing vise, take the easy way out. But unless my Google foo has failed me, I don't think these things exist anymore. Is that wild or what? I mean, usually in this whole human experience we share, if you have a problem, odds are someone else has had that problem. Though there is one caveat. Blacksmiths apparently use filing vices, or maybe they used to. I did find these, or variations of these, but none really for sale commercially. Frankly, I didn't look hard because these aren't quite what I'm after, but I bet they're handy. From what I can tell, it looks like these are meant to be used in a bench vise, so you squeeze these in the vise to squeeze the work you need to file, which is clever. I'll give those anvil smackers that. But because they're pinned, like they have a pivot like pliers, the jaw motion won't be parallel. These are probably sized for very specific tasks, but I want to hold anything from a kitchen knife to an axe, so I'll need a bit more range. First things first, I had to find 2 nesting tubes to create the body of the vise. These are a little lighter walled than I envisioned, but I think they'll do. Slop isn't too bad for a prototype vise anyway. You can buy nesting tubing. I think it's called telescopic or telescoping tubing. But if you got a scrap pile like I do, and you don't need a ton of this stuff, there's usually some combination that will fit halfway decent. Thin wall to thick wall or metric to imperial. This sort of stuff doesn't come up too often. And again, if you don't need a lot of it, I've usually been able to see my way through without ordering anything special. You may, however, have to get rid of the weld seam inside. I didn't here, but at times I've had to push a scraper or a file through there to get that welded seam out of there to get the fit that I wanted, or to just get them to fit at all. This is a prototype, by the way. I don't know if I said that out loud, or it might be a prototype. It'd be sweet to machine a really stout vise from solid stock, something heirloom, but I'm not even sure this will work, or if I'll want changes, so I'm going to go with a mix of machining and welding, something relatively fast. I could have 3D printed, I suppose, but if this works, I'd want more clamping power than extruded plastic might be able to give me. So we've got the tubes, body of the vise. These will get jaws machined and welded to them. And I plan to run a bolt through the top for the squeezy power. This one I think is a little short, but you get the idea. This will actually be part of the top jaw, and I'll need to make a nut that welds into the bottom of the moving jaw so that when I turn the screw, the vise clamps. This is much longer than I expect I'll need, but I do have this piece that's a pretty alright fit in there. So let's head on over to the lathe. In addition to what you just saw, I added a threaded hole in the end. If it weren't for my crippling stage fright, I might have shown that to you. The screw thread engages, I don't know, maybe about a ½ inch, perhaps a little more. There's a clearance hole that comes in through the bottom. I was going to get a longer screw, but here we are, aren't we? I'll have to scale this build down to match this screw length, but no big deal. That does mean my clamping range will be reduced. Clamping range would be this thread length, I don't know, -1 diameter maybe, so I'm still engaged. So 3/4 of an inch-ish. Full disclosure, I did mess this up. Despite the drawing being clear as day, I was convinced that this nut essentially went inside the smaller tube. But it doesn't. I mean, it does, but that's not where it goes. It's supposed to go inside of the larger tube. This way. That gap is going to be a problem for welding. So I machined a spacer from some solid stock. Not perfect, but that's going to be a much smaller gap to close while welding. Anyway, that goes there. On the flip side, I've got this counterbore cap. This does fit into and weld to this smaller tube, and takes the socket head cap screw, which also got a small groove cut in it to take snap ring. So that'll drop in there. Counterbore could have been a smidge deeper, but too late for that now. No sense crying over spilt coolant. And I think I'll drop a couple of washers on the back, and hopefully there's clearance to get a small snap ring in there. This will keep the screw captive with this cap part, with the top part. That will drag the smaller tube up and down. Now, one problem with that is that once this is all welded together, that snap ring will be inaccessible, unreachable. Not my smartest design decision, but probably one of my fastest. Just in case the drawing from earlier didn't really speak to you, this is what the insides will look like. The counterbore cap will be welded inside the small tube. Large threaded part will be welded inside the large tube. Lastly, I made some flat jaws. I mean thin. Are we still allowed to say that word? I don't know if you could see those pockets in there. They were milled at an angle, so they fit the tubing at an angle. That goes there. Something like that. Sorry I didn't show machining these parts, but they're just square pockets. And square isn't really the most exciting of shapes. To prep for welding, I gave all of the parts a stern and firm wire brushing. These almost look like cold rolled steel, don't they? Of course, when you do stuff like that, be sure to save your mill scale. You'll never know when you might need it. Now it's just time to... do you say we make pretend I haven't tried this already? I'm happy with how this thing's turned out. It's also a lot heavier than I expected. I don't know why I decided to braise it. That doesn't look too bad. I'm pretty sure I cooked the brains out of that plastic washer in there though. I did run a second weld bead over some of these welds just to fill them out a little bit more. I mean, frankly, the reason I thought brazing would have been better is because I think there's less deformation. Like if you put a steel tack on one end, it's going to pull that part out of square pretty hard compared to something like bronze, I think, especially with all that slop that I had in there. I may have made some sort of mathematical and or grammatical error. I was expecting a lot more range. That's pretty much just engaged. Yeah, that's maybe one thread. I've got a little bit more than half of an inch in there. I'll have to give that some thought, see where I lost that extra quarter inch or so. I even offset the bottom jaw. That was supposed to be flush. I noticed I was running out of range, so I just bumped it up a little bit. It's overlapped maybe 50-50. Now the thing I'm worried about, and the reason why you may have noticed the shims in the back here while I was welding the jaws on, the looseness in the parts might cause this to pinch at the back. Well, not stay parallel, and then the part in the vise might swivel. That'd be annoying. But then I realized I'm probably going to put some tape in here anyway. I don't know. I'll have to give it a try, see how it holds up. As is, it does a pretty good job of clamping. I also wish I would have done some of this finish machining, cosmetic machining, before I welded these parts up. In my head, it seemed like a smart move to finish machine sort of the perimeter and the profile of the jaws once they were squeezed together. So they end up being, you know, the same exact size and shape. But with this angle, it turns out it was a little bit awkward to hold onto. And the welding caused a little bit of deformation, you know, shifting of parts rather. I don't know if you can tell, like that chamfer tapers a little bit left to right, maybe a 1/16 of an inch thinner on this side. Not the end of the world. But some rounds would have been nice that now are almost impossible to put on. Anyway, let's give this a try. That feels pretty decent. It's got to go a little further out. You hear that? That's the sound of a clogged file. I'm getting carried away. This thing was already sharp anyway. I'm just now extra prepared for the zombie apocalypse. Seems like it's got a good bite on the fidget spinner. That is much more gentlemanly. Okay. I think I'm happy with how Project Single-Use Vise turned out. A little bummed I can't get the axe in here, though it may fit a hatchet. I'm going to have to think about what this might look like as all machined parts, like no welding. And two sizes might be nice, small and a large. Maybe a little bit smaller than this and maybe something much larger than this. Oh, maybe this could be longer and like two-sided, double-ended. Flip end for end in the bench vise. Oh, the sky's the limit. I'll keep you posted on how useful this actually ends up being. Oh, and if someone has found these commercially available, maybe you did some better Googling I did within the first 2 minutes of this video, please post the link below. As always, I enjoyed your company. Hope to see you again soon, and thanks for watching.